All right, sorry I had to start over. The recording stopped there. So we're going to pick up right where we left off. So now I'm going to go to 4b, which just means I want to simplify. So I just want to make, instead of having two parts of the denominator, I just want to have one part of the denominator. So instead of 2/4 roots in the denominator, I'll make it 1/4 root, and I'm just going to combine what I see here. So 2, 3 and 2, 1 can become 2 to the 4th. And y6 and y2 can become y to the 8th. And then I'm just going to do the same in the numerator. Instead of having 2/4 roots, I just want 1/4 root. And unfortunately, x squared can't combine with anything in the second 4th root, so I'll just copy everything. It's just x squared, 2, 1, and y2. The only difference is again, is instead of having 2/4 roots in the top, I just have 1. And now I'm going to go to my final step. I'm going to take anything perfect out. So I like to start with the denominator, and this is perfect. 2 to the 4th can become a 2. Y to the 8th is perfect. That can become y to the 2nd. In my numerator, x squared, there are not enough x's to come out, so that's going to be stuck in there. There's not enough 2's to come out, so that will be stuck in there. And there are not enough y's, so that will be stuck in there. And this is really a great answer. Probably the more traditional way you would see it written is that the 2 would be in front, and then the variables or the letters would go in alphabetical order. So either way, okay? So let's try a few on the next page. We're going to go down to number 1. So we're going to kind of nickname some of these steps. So the first step, I call it less is more. So I just want to take that fraction and try to simplify it. So 2/32, I can divide both of those by 2 and get 16 in the bottom. And then n2 and n3, I can just have an nb in the bottom. Now I need something in the numerator, so I'm going to put a 1. So that's the less is more. The second step I'm going to nickname as break it up. So instead of a fraction being under there, I'm going to break it up. So this takes care of the first rule that says no fractions can be under the radical. So now what I'm going to do is find a little spot. I need to make a factor tree for any number that I can. That will be 16 because you can't make a factor tree for 1. So just going through. And when I get done, I always circle the numbers that I can't go any further with. So what I'm going to do is just take this problem and rewrite 16 as 2 to the 4th power. So very similar to what you've already done so far on that pink page. And now I'm going to go to the second rule that says you can't have a radical. I cannot have this check mark down here. So I'm going to go through the process called rationalizing the denominator. So I'm going to multiply it, and I'm going to be multiplying the denominator with another cubed root because cube roots can only go with cube roots. And I want to have enough 2's and n's so that they are perfect. So when I look at the 2, I have 4 of them. If I just had 2 more, then the 2's would be perfect. And with the n, if I had 2 more, those would be perfect. And then I have this big spot in the numerator where something has to go, and that's where we go with whatever you did on the bottom, you do to the top. Because again, I'm just taking my original fraction times 1. This is 1. It's just a really weird version of 1. And now what I want to do after that is just clean up. Instead of having 2 cube roots in the bottom, I would rather just have 1 cubed root. So I'm going to combine these, and my 2's can combine into 2 to the 6th, and my n's can combine in n to the 3rd. Then I want to combine this, and nothing can really combine, and 1 times the other cubed root, that would just keep this as 2 squared n squared. And now I'm ready. I am going to take out the perfect stuff. Final step. So when I look in my denominator, this is perfect. It can come out and be 2 squared. This is perfect. That can come out and become an n. And this is not perfect, so it's going to be stuck in there. But instead of 2 squared, I'll put a 4. And this isn't perfect, so it'll be stuck in there. And this is a great answer. What would make it just a little bit better is instead of 2 squared, you had a 4 down here. So let's try the next problem, nicknaming those steps. So first, the less is more. Let's take 4/18, divide both of those by 2 and get 2/9. And let's simplify our r's to r to the 4th. The next step is break it up. It's already broken up. Don't have to worry about that. And the next thing I'm going to do is just make a factor tree for any number that I can make a factor tree for, and that would be the 9's. So the 2 is fine, and a factor tree for 9 is 3 and 3, so I'm not going to make that, but I know it's 3 squared. All right, so now I'm going to address again that second rule that says you can't have this radical in the denominator. So I'm going to do the process called rationalizing. Since I have cube roots, I'll use another cube root, and I want to have enough 3's and enough r's so that they are perfect. Because when it's perfect, everything comes out and there's no more radical. So I have 2 3's, 1 more would make it perfect, and I have 4 r's, 2 more, and that would be perfect. And in the open spot in the top, whatever goes in the bottom goes in the top. So now I'm just going to clean up my 2 fractions. So I'll start by the denominator. Instead of having 2 cubed roots in the bottom, I'll make it 1 cubed root. So I have 3 3's and 6 r's. And in the top, there's really nothing I can combine here, so I'm just going to rewrite it all. And now I'm ready for my final step. I will take out all the perfect stuff. So in the denominator, this is perfect, it becomes 3. This is perfect, it's r squared. In my numerator, there is nothing that's perfect. So 2 and 3 will be stuck in there, but I'll just make it 6 instead, and then I have r squared. All right, let's do number 4, and then we're going to start and finish the pink page that you have. So let's do the less is more first. Let's take 9/12, and let's just divide both of those by 3 and get 3/4. And then my ends, I can just have n3 in the bottom. Break it up, that's already been done. So my first rule is okay, I don't have a fraction under the radical. And now what I'm going to do is make a factor tree for any number that needs a factor tree. So 3 you can't really do anything with, but 4 I can break down into 2 and 2, so that's 2 squared. All right, let's fix the next rule that says you can't have this check mark, this radical in the denominator. So I'm going to rationalize it, and I'll put a 5th root with the 5th root. And I have 2 2's, 3 more would make it perfect. I have 3 n's, and 2 more would make it perfect. And the empty spot is whatever you do to the bottom, you do to the top. And now I'm going to combine. I'm going to clean up my denominator. So instead of having 2 5th roots, I'll have 1 5th root, and the 2's can make and combine into 2 to the 5th, and the n's can combine and n to the 5th. And I'll do the same for the numerator, but nothing can combine, so I'm just going to rewrite it. I have a 3, I have a 2 cubed, and n squared, and now I'm ready to take out all of the perfect stuff. So in the denominator, this is perfect, it's 2, this is perfect, it's n. The 3 is not perfect, it's stuck in there. The 2 cubed is not perfect, but I'm just going to change that to an 8. It is stuck in there, and the n squared is stuck in there. And this is a great answer. What would probably make it just a little better, not probably, but would, is changing 3 and 8 into 24. And that is your final answer. So we're going to be going back to the other side of the pink page in a different video.